Hello everybody, this is Jim, and today we're going to be going over some more mates in the assembly models in SolidWorks. So today we're going to be going to come over some of the more advanced mates as well as the mechanical mates. So under advanced mates, we're going to go over how to create symmetric mates, width mates, linear couplers, uh, distance and angle limiters, as well as profile center mates, and we're also going to go over some more interesting mechanical mates, which is more specifically the cam mates, the gears, and also rack and pinion. So let's go ahead and let's take a look at what I've got for us today. So I've already created a few parts we're going to be using as examples. So we're going to go over what each of these parts are going to be doing once we get SolidWorks up and running, which it is. So new document, and let's open up the assembly. So I'm going to import this slide block first. So I'm just going to drop this block into place. So it's just a block with a groove down the middle that allows something to slide up and down. And I'm going to drop in the slide part. And I'm going to make it coincident with this surface here. So I'm going to go like that surface, select that surface. So I'm free to move this all around. I can move it left to right, but let's just say I want it to split the distance between both walls. So under the advanced mates, I come over to width, and what we see under here is the first selection box. I select two entities to set the width. So I want to split these two walls here. So I'm going to use both these to set the width of the mate. And now I need to give two tabs that will split the difference between the two walls that I selected. So I'm going to select this wall and this wall, and that adds the width mate. So I can move it up and down, but I can no longer move it left to right. It'll always be in the center because of that width mate. So let's see what else we can do. Let's insert another slide. We're going to mate it. Advanced mates. And we're going to put another width mate in. So I'm going to select this wall, this wall, this wall, this wall. That'll lock this one in place as well. So I'm going to go ahead and I'm going to create what's called a symmetric mate, because what I want these two slides to do is I want them to always be equally as far away from the edge. So what can I do that? So like it entails, it makes a two faces symmetric about a plane. So first I gotta create a plane. So I come here to references, plane. I add select that surface. I select this surface here, and I'll create a plane right in the middle. Select that OK. Now I'm going to go into mate, advanced mates, symmetric. So the symmetry plane I've got selected as this plane right here. Now I got to select two surfaces to make symmetric about this plane. So I'm going to select this surface, and I'll select that surface. And now when I move one of these, they always stay symmetric. So let's say I wanted to create a mate that will allow them to go to the edge but not go off it, and also come to the center and not go through each other. So I can do that with a distance limiter. So let's take a look at that one. So let's go mate, advanced mates, and go down to here. So you see distance under advanced mates. It's not the same distance as we see under standard mates. Standard mates, whenever you put it in a distance or an angle, it locks it into that specific angle and you can't move it away from it. So this one's a little bit different. So under distance, this first distance is the default position between two surfaces. So first I'm going to select my two surfaces. I'm going to select this surface and this surface. And I'm going to try to put in some some constraints to allow them never to go through each other or go off the edge. So at 0, that's the point. That's going to be our minimum distance. So if you come over to here, I can enter my minimum value. I'm going to leave it at 0. Now I got to find this maximum value. I don't know what that is. I'm just going to make it something for now, because I can never set this distance beyond what my maximum value is going to be. So I don't know what that is. Let's see what that is. Go to 12. I go off the edge. Let's see, 8. That's not enough. Probably 10. 10 looks good. So I'm going to set my maximum distance to 10. And hit OK. Now I can move these slides. They don't go through each other, and they don't go off the edge anymore. Pretty interesting stuff. So I got this in. Now I want to do create what's called a linear coupler. So what that does is it couples the motion between two parts to each other. So let's just try it and not think too much of it. So let's go ahead, and I want to get rid of this distance mate. I want to get rid of that, and I want to get rid of the symmetric mate as well. So I'm going to bring this in a little bit closer. Go mate, advanced mates, and I'm going to select linear coupler. So under this mate, what it allows me to do is allow it to input a ratio. So for every 1 inch blue surface I select, this purple one will go, say, 2 inches. So I'm going to select my surfaces. So I'm going to select that surface. That's my blue. There's my purple. I'll select this surface. You don't need to worry about inputting anything here for now. I've never needed to worry about that. So let's go ahead and let's just hit OK. So for every 1 inch I move this slide, this one's going to move 2 inches. Let's hit OK. See what happens. So I move this, and that block is moving twice as fast. So pretty cool. So that's a good introductory to how to create symmetric mates, width mates, linear couplers, and distance profile limiter. Let's go over profile center, because I want to spend a little bit of time on angle limiter, because that one's got some neat tricks to it as well. So let's go ahead and let's just delete everything I got in here. So I'm just gonna create a new assembly. I'm just gonna insert this plate here. Just drop it in. Now, what the profile center does is it allows me to center two profiles on each other. So it is what it says it is. So if I input this cylinder, let's say I want to put this cylinder right in the center of this plate. I don't really have any features to really on this cylinder to really lock it into the center place. So I can use the profile center. Just select this surface here, and then select this surface here, and it's going to lock it into place just like that. I can do that with pretty much any objects. I can bring in this dome shape as well. I can do the exact same thing. I've also got other kinds of options. I can offset it as well, flip the dimension, and also lock rotation where it will no longer allow it to move. Okay, so that is the profile center. So I want to go over how the angle limiter, because this one's got some interesting features about it. So I'm going to create a hinge assembly. So I'm going to import this hinge, just drop it in. Pretty straightforward. insert another component, second hinge, and I'm going to mate these two. Oops, nope. Mate these two together. Okay, I'm just going to lock this in, make it touch, lock it in like so. And I'm going to import this pin. Not that it's necessary for the assembly, but just because I have it, and I'm going to put it in. So mate, concentric. Okay. So I got this hinge set up. So I can swing it around, but it goes through, they go through each other. I'd like to put in a limiter which would allow this thing to swing around but not go through. So there's an interesting feature under the move component tab. So let's click on move component. Let's see what we got. So under options, it allows us to have collision detection. So let's click on collision detections, and I'm going to check stop at collision. So when I swing this hinge, it'll stop whenever it collides with the other hinge. So what I'm going to do is I'm going to leave it in this position, and I'm going to get a measurement. So let's go and go to evaluate, select measure. I'm going to select this surface and this surface. What's it measuring? 89.86 degree angle between the two. I'm going to write that down. It's 89.86 measured clockwise. So 89.86 clockwise measurement. Okay. I'm going to do the same thing and move it around to the other side. So I'm going to go move component. Collision detection. Swing it around. Stop it right there. I'm going to evaluate, measure. I'll do the same surface, same plane. So here, here. I've got, what is that? That's 168. That's a weird angle to measure by. I'm gonna get the inside measurement. I'm gonna go here, here. I like that one better. 11.16. That's 11.16 measured clockwise. Yeah. Okay. So now I want to go ahead and I'm going to put the mates in. So I'm going to go back to assembly, to mate, advanced mates, angle limiter. So I'm going to select this surface, that surface right there. See what happens when I go to 0. I go to 0, it goes out to there. Go to 30, it goes to there. I'm going to flip the dimension. I want it to go counterclockwise. When I'm putting in my mates. So 90 degrees. So I want to go up to 270. That's okay. So that's going to be my maximum value. I go back to 0. My maximum value is going to be 270. And my minimum value is going to be negative 11.16. That should lock everything in now. Let's give it a try. Let's see what happens. Look up here. Yep, it doesn't allow me to go any further. I go around. doesn't allow me to go any further. So this one you'll have to play around with and get used to it. Sometimes you'll have to go back in here and look at it. Sometimes you'll have to flip the way the dimension is being taken. So it's good to just kind of practice with it, and also to maybe change whether the angle is aligned in line with the plane or anti-aligned. So it's good to go ahead and just give it a try and play around with this one. This one takes a little bit more time to get used to. Okay, so that does it for the advanced mates. So I want to go over some of the mechanical mates because those are way more fun. So I'm going to go over how to create cam, gear, and rack and pinion mates for this lecture. So I want to go and open up an assembly that I've already made. So I'm going to go back to lecture 10 examples, mechanical mates, and open up this assembly right here. So this assembly I've already got made, and I've got a couple gears in here. I've got a rack, and I've got a cam and a cam shaft here. So if I move this rack and pinion here, what I should get, it should rotate. Let's see, I don't have this gear anymore to make this go up and down. Once I do, if I rotate this cam, this shaft will go up and down along the surface. So I'm going to go in and I'm going to delete all my mechanical mates. We're going to go through them one by one. Let's delete those. Delete. Okay. So first I'm going to start with these here. So these call for a gear mate. So these two are both the exact same kind of gear. So this should be pretty straightforward. So go to mechanical mates. Let's click on gear. So when it asks me for the mates and mate sections, it's asking me to give it two circular inputs. I can just select this line right here, this line right here, and it'll take it. So let's go ahead and let's take a look what happens. So I'm going to select that line, and I'm going to select that line as well. So if you look down here, it goes down to the gear ratio. Now it's pretty good practice to go ahead and input the pitch. So whenever the pitch diameter. So I could have, if I had the a circle on the pitch diameter already inputted onto my parts, I could have just selected that and it automatically imports that. So this is going to input the diameter of whatever circular entity I happen to select. So if I were to select this inner circle right here, this would have been like 0.5. So but I can go in and I can manually change it. So what am I talking about? I'm talking about pitch and whatnot. So let's go. I'm going to go to make master car, and I'm going to quickly explain that. So let's see, what's this part number? Let me go back out here. Let me cancel that. This is 6529K230. So 65 29K230. So let's take a look. So the pitch diameter is the diameter in which the tooth of the gear is going to be making contact with the tooth of the other gear. So the pitch diameter for this one is 2. They're both 2. So my gear ratio is going to be 1 to 1. So I'm going to go mate, mechanical mates, gear. It's good practice to make sure that these gear teeth are already aligned, touching each other. So that looks good. I'm going to select, let's just say I'll select that surface and I'll select that surface. Just show what I'm talking about. So both pitch diameters are 2, so I'm going to put 2. I'll put 2 in here as well. I'm going to hit OK. So now once I put that in, when I rotate this gear, this will rotate at the right ratio. See, those teeth don't comply. So they don't comply because the pitches of the 2 gears need to match each other. That's basically the number of uh, teeth divided by the diameter of the gear itself. So the pitch on this is 10. The number of teeth is 20, and the pitch diameter is 2 inches. So let's keep going. Let's see what else we can do. So I want to be able to transmit motion from this gear to this gear. I got that from my gear mate. Now I want to be able to transmit the motion from this gear onto this shaft as well. So that'll just be a straight one-to-one gear mate. So I'm going mechanical mates, gear. I'm going to select this, and I'll select that. Why is it doing that? Delete that. So let's delete. Select that surface, and then select that surface. Okay, that's what I want. I want one-to-one. And hit OK. Now when I rotate that, you can't really see it, but this shaft is going to rotate as well. So let's come over here, and I'm going to put a gear ratio between this gear and this shaft at 1-to-1 as well. So I'm going to mate, mechanical mates, gear, select that. Let's delete that old one, and I'll select this as well, and I'll make this 1-to-1. Okay, so now when I rotate this gear, I'll be able to transmit motion through the shaft and to this gear as well. Okay, so now I want to be able to transmit motion from this gear to this bottom gear. So let's take a look. This number is 6867K410. Let me pull that up real quick. 6867K410. Now let's take a look at that. So product detail. Let's see what information I can get. So my pitch on this gear is 16. The number of teeth is 16, and the pitch diameter is 1 inch. So let me see what the pitch diameter of this one as well. So this part number is let's see. Come on, load up. K520. Okay, so that is 6867 K520. Let's take a look. Alright, so my pitch is going to be 16. The number of teeth is 48. The pitch diameter is 3 inches. So this is going to be a 3-to-1 gear ratio. The pitches both match, so the teeth will mesh nicely. So let's go back into our model. I'm going to get it so the teeth are looking good. Teeth look good. So I'm going to go mate, mechanical mate, gear. I'm going to select this gear and that gear. And I'm going to go 1 to 3. So it shows it right there. So teeth diameter is 1, teeth diameter 3. Let's go OK. And now when I rotate, it'll rotate that gear as well. So let's go ahead and let's look at this rack and this rack. Let's go over the rack and pinion mate. So I'm gonna go ahead and I'm gonna line these teeth up about as best as I can get it. So let's go to mate. Let's go mechanical mates, rack and pinion. So first I'm going to select an edge of the rack. So I'm going to select the edge of this rack here. And my gear, I'm going to select this right here. Why is it not selecting? Oh, I got the face, that's why. I got to get the edge. And now I can select this gear. There we go. Okay. So I'm going to put in the pitch of the pinion. So the pitch is 3 inches. And that should be all I need. So I'm going to hit OK. And now I should be able to move this and move this smoothly. Okay, so I got it backwards. I need to go back in and reverse that mate. So I'm going to go back into mate, rack and pinion, edit feature. And I'm going to click on reverse. That should clear it up for me. So I should be able to slide this, and that slides nicely. So it all looks good. So if I move this, and everything moves the way you'd expect it to. Okay, so I'm going to go ahead and I'm going to add in another gear mate with this gear to this shaft. So let's go gear, select this body, go 1 to 1. Now let's see, the cam doesn't move yet. So now I'm going to go ahead and I'm going to put another gear in, gear mate, so it's like that. And I'll select that. And I'm going to go 1 to 1. Now this cam should rotate. The cam does rotate. So I didn't get that cam made out. Let me go ahead and let me delete that. Let's go over how to create the cam mate. So I've got this cam here. I want it to be able to move up and down on this boss here. So let's go ahead and let's take a look at that. So mate, mechanical mates, cam. So I first select the path at which the cam is going to follow. So I'm going to select this top surface here, and it looks like it'll select all surfaces that are tangent to the surface that I select. The cam follower. Now you have to select a point. So I went ahead and I created a point on this shaft here. So I'm going to select this point, and this point is always going to be touching the path of the cam. So I'm going to select this point and it'll lock it down like that. So now whenever I move it, this cam will follow. Alright, that's going to be the introduction to advanced mates as well as mechanical mates. You should have enough knowledge now to be able to complete the project of the gearbox. So if you have any more questions, feel free to let me know. Other than that, have a good one. Bye bye.